Hi guys. Let's take a look at number 8. This is from Lesson Master 6-7A. So this is from the Lesson Master packet that you took home with you yesterday and are working on over the weekend. And in my previous video, I worked through number 7. So that's all these scribbles that you see out here on the outside. I'll use a different color to go through number 8. That way we're not confused. So there's a lot of parts of number 8 that are similar to number 7. However, we do have to set it up with Newton's formula first. So even though it doesn't ask us for an equation, we need to write an equation to be able to answer the question. Okay? Okay, so here's my pal Newton, -1/2 gt squared plus v sub 0 t plus h sub 0. Okay? I am measuring in meters here. I have meters and meters, so that means my g value is going to be it's going to be 9.8. So -1/2 times 9.8 t squared plus an initial velocity of 75 plus an initial height of 2.3. Okay? And then I would probably take that equation and make this, like when we write it out in a second, I'm going to make that a -4.9, just so you don't get confused about where the -4.9 comes from. So this is Newton, but this is asking us to do something different with Newton than we've done before. So far with Newton, we've talked mostly about things like what is the maximum height, or how long before it hits the ground, or how high will it be at a given time. Now I'm asking you to find the time that it's a certain height, okay? So to do that, there is a way to do it on your calculator. It's a little bit complicated, but if you want to know, ask me on Monday and I'll show you. When was the rocket 100 meters off the ground? That 100 meters is the height. So I'm going to put 100 in for h, and that's going to look like this. I don't know why I just switched colors on you. It's going to look like 100 equals -4.9 t squared, because remember I said I was going to simplify that, plus 75t plus 2.3. And then I'm going to take off the 100. Take off the 100. So now I have 0 equals -4.9 t squared plus 75t. Let's see, 2.3 minus 100 is going to be -97.7. Okay, and once again, to solve something like this, to look for the time, I'm going to do quadratic formula. And I'm not going to do that here. If you're still stuck on quadratic formula, I suggest you look back at your notes and some of these examples we've done. But we've done a ton of quadratic formula already, so not going to take the time now to do it. But you go ahead and finish that up so that you can answer part A. Okay? Now, and there's going to be 2 answers there also, remember, because you're going to hit 100 meters going up and going down. Okay? Here's your parabola. Okay? 100 meters maybe is here, let's say. You're going to hit it once going up and once going down. So that's why you get 2 answers. Okay? And both answers are correct. Now for B, when did the rocket hit the ground? Looking back at my original equation, what can I plug in? Well, when I hit the ground, that's a height of 0. So I can go to this equation and put a 0 right here and make it 0 equals -4.9 t squared plus 75t plus 2.3. And once again, to solve quadratic formula. I think you guys can take it from there. On that one, by the way, that one's going to be a little weird. Actually, let me draw a little picture of what that's going to look like. You're going to get 2 answers again, but you're going to get a weird 2 answers. I'm just making this up. I don't know the actual answers off the top of my head. So this is what you're looking at. When you do the quadratic formula and look for when you hit the ground, you're looking for this point. And you're going to get some answer that makes sense. Again, I have no idea what the correct answer is. Let's say you get x equals 8. Okay? That would mean after 8 seconds, 3, 4, 5, 6, 7, 8, we're hitting the ground. Okay? But you're also going to get some weird negative answer, like x equals -0.2 or something like that. Again, not the correct answer. What that is really telling you is if I looked at the rest of this parabola, if I extended that downward, that's giving you this point. But that point in real life doesn't really exist. We're launching off a platform. We're not launching off the ground. So this part of the rocket's journey didn't actually happen. So just disregard that negative answer that you get. This is the answer that you're looking for. But in one like the previous one about the 100 meters, because those both actually happen, both answers are correct. Okay, so you just have to think about what it's asking you for before you decide what to do with those answers. Okay, so again, I'm going to leave the quadratic formula to you, but quadratic formula here, quadratic formula here, and then that's A and B. Okay, and that's all there is to that one.